Welcome to Nomad PHP Lightning Talks. I'm Joe Ferguson. Nomad PHP Lightning Talks are a 10-minute talk that gives a high-level overview or an in-depth look at a small portion of a PHP-related topic. Lightning Talks are a great way for new speakers to build their speaking resume and for longtime speakers to test drive new talk ideas. Right now we have Chuck Reeves, and his talk is called Stop Multiplying by 4. Make sure you visit Joined In after the talk and leave Chuck some feedback. Chuck, take it away.
All right. So once again, I'm Chuck Reeves, everyone, and this is Stop Multiplying by 4. I'm a PHP developer about 15 years, and I started getting into estimation when I started contracting about 6 years ago. So I was listening to a Dev Hell podcast, and normally I would play a clip from it and make fun of Chris Hargis, but since it's his birthday and this is a lightning talk, I figured I'd exclude that. But anyways, let's get into estimation. So the first thing I want to say about estimation is that you're going to get it wrong. And the reason why you're going to get it wrong is because of something this man said. The future is not written yet. No one's is. So what we're trying to do with estimation is reduce how wrong we really are. Now, believe it or not, we do a lot of estimation every day, and we're surrounded by it all the time. For instance, if I were to ask someone how long would it take for them to get to work in the morning, they have a general good idea on how long it's going to take them and how much time they would need to get to work on time. So what can we do to take these things and apply it to an actual software project and what we're going to be estimating? So first I posed 3 questions. The first question is, what is estimation? Is it just time-based? And no, it's not. We also need to estimate how much servers we're going to need, how much time we're going to need to test, how many users we're going to have, how we're going to scale out, and all those. The next question is, why should we even estimate when it comes to dealing with time? We hear stories about Spotify and Google where they don't have deadlines, but estimation is not just about time. Estimation covers a lot of different areas of it. And then finally, why should we, the developers, estimate? Shouldn't we just leave it up to our product managers and project managers? Well, the answer to that is no. We're the ones who are doing the work. We are the ones who are going to have a good idea about the amount of effort that's going to be needed to go into the feature or bug fix or whatever is being asked of us. So we should really be involved in this dialogue on what's going on. So the problem that we have when we're estimating is that we tend to think of estimation as a simple solution. 2 plus x equals 5. We can easily solve for that because this is a process known as deduction. However, when we're estimating, we're really looking in the realm of 2 plus x equals y. This is what's known as induction. And there's a whole philosophy based on this right here. But really what we're trying to do is, in order for us to solve for x, we need to get a good idea of what y is. So what can we do to figure out what y really comes down to in terms of induction or an estimation? Well, requirements are the big key right here. And Galileo actually said this quote right here, which is really great, but it builds up into the fact that we need to define what we're going to be building out or what we're going to be estimating in order to come up with the amount of effort that is going to be needed to complete that task. So I'm going to start off this whole talk with a simple contact form right here. Now let's imagine that we get this kind of contact form coming in from a product manager or sales manager, marketing team, whatever. Now, this feature that's being requested of us, I don't like the way it's being presented right here. This has a lot of wordy expressions inside of it. We don't care how awesome the service is, and we need to find an easy way. There's too much here describing what's going on that is not going to help us figure out what really needs to be done. So one thing we can do is, let's just simplify it down. We have here a contact form for the field email and a valid phone number. This is good, but it's leaving out a key component for me, which is actors. So we want to know who's doing something and what are they doing. So in this case, we have sales and leads. Next, we'll come into here, and we'll see that we've refined it even more. We put in the actors, who's doing what and why and where. But there's still something wrong with this, and this has a misplaced modifier. So in this example, name, email, and valid phone number. Well, is only phone number supposed to be valid? Does the email have to be valid? I'm doing little air quotes here. And also, when we come down to it, we really need to quantify everything as simple as possible, make everything clear and concise so that we do not have ambiguity when it comes to our requirements. Now, misplaced modifiers were made famous by Groucho Marx. Here's one I found on Twitter a while ago. I find it kind of funny, but it gives you an idea of how things can be misleading, especially in the English language. So now that we've reduced our misplaced modifiers, our wordy expressions, we see that we have our Nice, clean, concise form right here. Now, with this one, I have a small problem because what is a valid phone number? We need to clarify this even more. The examples I'm showing on the screen right here are all valid phone numbers. Do we want someone to be able to enter 911 so we can call them back and sell our product? That seems kind of silly. Or even 1-800-mattress or the White House. Yes, these are all valid numbers. What I like to do when I'm gathering requirements when I'm contracting is I look for what I like to call requirement smells, which are kind of similar to code smells. They're just things about the requirement that sort of get at you, that nag at you. And here's a simple list of some things you can do. So, and I'm going to keep this list up here. I'm not going to go through them one by one, but if anyone can tell me what user-friendly is, I will gladly pay you $100. I have seen that come up many times in requirements, and I don't know what user-friendly actually means because it's so broad. And also, when you're making requirements, be sure that you include the technical or functional requirements. For example, what is our encoding going to be? What are the fields in the database going to be? Now, if you notice here, for the phone number, it's got to be less than 25 characters, and now we're going to be validating with some foobar REST phone service out there. So now our original estimate of, oh, I can do a contact form really easy in 5 minutes, is normally the first thing you learn after a hello world. Now I have to talk to a third-party service in order to validate this phone number. And now our original idea of what was entailed inside of this requirement has now grown. So it's very important to be clear, concise in requirements. So now we've gotten all the requirements, we got all the functional requirements, what can we do? Well, the first step is to break things down into smaller components, because then we can be certain about some things and uncertain about other things. And the things that we're certain on, we're going to be more accurate in what we're coming up with in terms of effort to get done. So an email lookup service in the database to make sure it's unique, that's very easy to do. Form logic is very quick right there. The UI component, once again, all very simple, but now we have this phone validation service right here. We've never used this before, so what are we going to do? What the first step to do is to try to take in historical data and see, okay, I've talked to a third-party service in the past, especially a REST service, and it took me about this long to do. The reason we're doing this is now we have a rough idea on what we've done in the past and how we can transpose it to what we're trying to do right now. So for example, if you talked to the Twitter API in the past, you already kind of get an idea on how to make curl requests and get data back and handle errors right there. This is not all that dissimilar. So what can we do to improve upon this? We're about 80% there or 50% there already. Another fun thing that you can do is just write a simple unit test for it. Talk to this third-party service and just throw numbers at it, see what you get back, see what errors you get back, see how you can transpose the data into something that you can use. And then later on, you can build this up. And finally, the last tool that I like talking about, and that a lot of estimators are going to tell you, is the confidence interval. We're already familiar with this concept of what a confidence interval is. If you ever seen the news in the morning and they come up with the weather and they say the high is going to be between 40 and 30 degrees, then you know that somewhere throughout the day, the temperature is going to be between there. That's what the confidence interval is. Statistically, it is you are 90% confident that whatever you're estimating, the true value is between those two numbers. Now that we've got a good idea of what our different tools are, what can we do to start coming up with our estimations? Well, the first thing that we do is just come up with any number. Throw a number out there, put it down on a piece of paper, then go away to lunch, come back, digest it, and try to see if you come up with the same number again. The reason for this is you've had time to sort of digest and think about the estimation. When you're doing it for the first time, you may be thinking, oh, well, you know, I got this. And then you go to lunch and all of a sudden you're like, oh, wait, I've already seen that. I found this library on GitHub that already talks to it. I can already use this. The next thing that we can do is list out the pros and cons of us being on time with our estimate or being off our estimate right there. This is going to help eliminate bias and try to think of some edge cases that may come up. And finally, the last thing I appreciate is the absurdity test. This one is hysterical because you can really go outlandish with it. So if I were to ask you what the wingspan of the 747 is, you can go crazy with this number. You can say, well, it's not a mile long. Can't be a mile. And then you just come down. It's like 500 feet? Yeah, maybe 500 feet or 300 feet, maybe 200 feet, and you just keep going down. You start on really far off absurd ranges and then refine them down. And the last tool that we can use is what's known as the equivalent bet. And this one is fun. And the way it works is I'm going to show you this. Imagine we have this wheel that if you spin this wheel, you have a 90% chance of winning, but you have a 10% chance of losing. Now, what you're going to do is you're going to bet on winning in the wheel or bet on your estimate. Now, what this is going to do is you're going to decide between the two. Those who decide to take the wheel, spin the wheel and have a 90% payout right there, they tend to be underconfident in what their estimate is. So therefore, you should go back and try to refine it even more. Now, on the flip side, those who just decide to take what their estimate is, they tend to be overconfident. They think their numbers are going to be correct, so why have a 90% payout right here? So when you're thinking, oh, am I going to spin the wheel or is my estimate good? You want to be in a realm where I don't know what is the best way. That's most likely your intuition kicking in and then saying, oh, I have a pretty good idea of where my estimate's going to be. Now, all these things I listed right here are pretty good if you're just doing estimation by yourself. When you're going into teams, you can sort of expand this out even more. One of the easy things that you can use is what's known as fuzzy logic or t-shirt logic. Now, Steve McConnell that I have cited down here, he aggregated a bunch of industry standard right there. If you were to take your feature and give it a size, small, medium, large, whatever, this is sort of industry standard on what it came from IBM and Cisco and Microsoft. This is about the average number of lines of code you're going to do. Now, you can transpose this into your own numbers as well. PHP LOC is a great way to see how many lines of code you have, how many classes you write, how many methods per classes, and then you can even tie this out, compare it to Git, and then see how long you're doing over a certain sprint or a certain cycle, certain time period, whatever. The numbers I show here are industry standards, and you can certainly modify these for your own. So now we can go into, let's say, our integration with the foobar REST service and say, you know, it's a very large right there. It's probably going to take me a lot of lines of code. And we could have verified that with our unit test right there. Another one that's really great to do in groups is what's known as Wideband Delphi, or it's often considered a group. And the way this works is you have normally the project manager, but someone is not estimating. What they're actually doing is they're collecting numbers or estimates from everyone on the team. They're secretly counting all the numbers and coming up with the averages. When they come up with the average, they come back and say, on round one in this example, we had an average of 6.5 hours. Does everyone agree? Now, the person in here who said 2 hours goes, well, that's too long because of this. But then the person in round one who got the 9 hours can then go and say, oh, well, you're not thinking about this project or that feature or this edge case right there. And now the person who originally estimated 2 will go, oh, that's right, I never think about it. And then you recast again. And once again, in this example, we came up with 6.8. You can come back and go, it still doesn't seem right. And you do it again until you get down, and everyone who votes gets to decide whether or not the number is correct. And this is really based on the law of large numbers. So what you do is you're trying to get a lot of numbers in there to get your aggregate or your average in the center, and then everyone votes on it, and this is the number you're coming up with. Now, no estimation talk is going to be valid without talking about Bayes' theorem. Now, Bayes' theorem is very simple. I have it up here on the screen, and really it spawned this whole science on Bayesian inference and Bayesian statistics and all that. But really what it comes down to is when you get more information, your likelihood of uncertainty will decrease. So you need to re-estimate. As you get more information on the probability of something, you need to change your decision and remodel your thinking. Once you're done with all of your estimations and you have all your features done, what can we do then to decide sort of our priorities and everything? Now, if you were going to ask someone or a product owner or product manager, give me the priorities, high, medium, and low, I can tell you all of you are going to agree with me, 80% of all the features and tasks will be high, 18%, around 15 to 18% will be medium, and about 2% of them are going to be low priority. So one way that you can eliminate sort of this bias, because everyone wants their task done, is what's known as the priorities matrix right here. And the way this works is you can get a whiteboard, you just make the grid of important, non-important, urgent, and non-urgent. You take all your features on cards and you put them in one of the 3 boxes that I have labeled here. And then this decides where your priority is. So you go, feature A, is it urgent? No. Okay. Is it important? Yes, so now it's your medium priority versus feature B, which is urgent and important, so now it's your high priority. One of the last things you can use when you're in a large group setting, or even if you have a huge company, is this priority spreadsheet, which you can download at the link at the bottom and check it out. Basically what this does is you have developers fill out what the dev cost is and the dev risk. So the dev cost is how much effort it's going to take. It's on a scale of 1 to 10. And the dev risk would be how complex the code is and how many bugs it can potentially introduce, also on a scale of 1 to 10. And the product owners put in their value and what their cost is, and this sort of comes up with the priorities as they present themselves. So if we look here, our leads UI is actually at a higher priority than the phone validation, mainly because what we're seeing here is that it adds more value to the company. So we want to try to get this feature in place for us. So now we have our priorities done, we have our estimations done. Let's talk about some of the politics that come into play, because everybody's going to want everything done. They're not going to like what you have to say. The first thing is you have to remove people from the problem. Everyone is going to want their task complete right there. You need to focus on what's best for the company or for the project itself. Focus on the interests. So for example, if you come up with something that says it's going to take between 6 to 7 months to complete, and you get pushed back from that, maybe that person has a trade show that they're going to in 5 months. So you find out this information and go, okay, so what do we need to get done for the trade show so that you can rock it out over there, and then gives us another 2 or 3 months to complete everything else up that we need. Focus on what's best for the company. Never negotiate your estimate. Keep in mind, we're in charge of the code. We're going to be the ones that are responsible for the bug fixes late at night, for deploying hot fixes to production at 5 p.m. on a Friday, which we don't want to do. We really need to be in charge of it. I give the example all the time. If you were at a doctor's office and they said you needed surgery, and they said it was going to take 6 hours, so you go in, you start getting your surgery, and you just before you go under, you see the doctor over there washing his hands or her hands, and you go, "Hey doc, what are you doing? Stop washing your hands, get in here, cut me open. I got things to do." The doctor's going to laugh at you. They're going to continue washing their hands. We are responsible for the code, so why would we go ahead and just negotiate down and say, nope, you know what, I'm just going to go ahead and do it right here. We really need to take charge of it. Now, some final thoughts on estimation. I prefer hours as opposed to days or story points. There's something a little bit more tangible. They're a little bit easier to scale out. If people come in late to work one day, they can stay late, make up lost time that way, whereas a day sort of becomes amorphous. I myself, I have a very specific window when I commute into my office right now that I need to take a train between 5 and 6 a.m. and leave before 5 and 6 p.m. Otherwise, I'm going to get home really late. So hours tend to scale a lot better than days do, because days tend to be a little bit more amorphous out there. Throwing more people or developers at a problem is not going to solve it. I always use the adage, it takes 9 months to make a baby. 9 women can't do it in 1 month. You have to really focus down on what has to be done, what can be done in a certain amount of time, and it goes back to focusing on the positions. Look what's best for the company and getting things done in a timely manner. And as always, iterate and be honest. As I mentioned a couple of slides ago with Bayes' theorem, as we get more information and we find out more things, we have to be honest and open. So for instance, if we're working on this food bar REST service and we give it a valid phone number and it's kicking back all sorts of crazy errors, you put a support ticket in right there, go back to the product owner and say, hey, you know, I gave this number right there and it said it was invalid, but now it's not. I submitted a support ticket and we're not going to get this done on time. That gives the product owners and managers time to readjust everything and readjust their priorities down. So now I know this is sort of a lightning talk. I was going kind of fast. That's kind of the point of this whole thing. If you want more information, I'm going to give 3 resources right here. One of the best ones is software requirements. This is version 2. I do believe there's a version 3 out, but this is more based towards a product manager, how they can go ahead and list out all their technical features, get everything that they need, how to present it to product owners, etc. It's more geared towards product managers, but it is a good way to get an idea of how to really refine down your requirements, talks about use cases as well. The second one is software estimation. This one's also geared towards product managers, and it takes basically all the the wideband Delphi and the t-shirt sizing, everything that I just gave you right there, and expands it out. It talks about if you're in a small group or a large group or even a medium group, different techniques that work great in those types of settings, and it expands out even more on how to present it back to product owners. And then finally, this book is my absolute favorite book, How to Measure Anything. Now, this book is not geared towards software estimation. It's geared towards just measuring data that you get. What's great about this book is that all the math you're given, you're actually given inside of Excel, so you're not overburdened with a lot of statistics, but you get into how you can actually run simulations, how you can find value in information that you have, and then expand upon it and actually come up with really accurate models, statistical models that are used by Fortune 500 companies, by NASA, by investors on Wall Street, and really drill down to coming up with actual predictions that you can really have a good backing on. So that was it. I thank you guys very much. Please go ahead and rate my slides on Joined In right there. I hope you guys had any questions. If you guys have any questions, feel free to contact me on Twitter. I'm @manchuck. And yeah, other than that, thank you guys very much.
Awesome. Thanks for joining us for another Nomad PHP Lightning Talk. If you'd like to give a lightning talk, please email me, joe@nomadphp.com. Please make sure you visit Joined In and leave Chuck some feedback.